Imagine a comet so ancient, scientists believe it formed 7 billion years ago, older than our sun itself. And right now, that comet, named 3I Atlas, is streaking through our solar system. According to new data from the James Webb Space Telescope, this interstellar visitor is releasing more carbon dioxide than any comet we've ever observed. And it's doing so while still millions of miles from the sun. In this video, we'll break down what Webb discovered, why it has scientists baffled, and how this one object could upend everything we thought we knew about comets from other star systems. Meet 3I Atlas. The name might sound like alphabet soup, but it carries a cosmic significance. The 3I prefix means it's only the third interstellar object ever detected passing through our solar system. The first two were the famous ʻOumuamua in 2017 and Comet 2I Borisov in 2019, and Atlas comes from the survey telescope that discovered it in July 2025, when this visitor was still about 4.5 times farther from the sun than Earth, roughly 670 million kilometers away. In other words, we spotted it way out near Jupiter's orbit, long before it ever neared the inner solar system, and Atlas comes from the survey telescope that discovered it in July 2025. Now, just how big and fast is this thing? Try enormous and rapid. Hubble data suggests 3I Atlas's solid nucleus could be up to 5.6 kilometers across, about 3.5 miles, potentially the largest interstellar visitor we've ever seen. That's like a mountain flying through space, and it's barreling along at incredible speed. By the time it slings around the sun, 3I Atlas will be racing at nearly 68 kilometers per second. That's roughly 152,000 miles per hour, or about 42 miles every second. At that speed, it could zip around the entire Earth in under 10 minutes. Even out in the depths of space where it was found, it was already moving over 130,000 miles per hour. In short, this cosmic wanderer is huge and it's fast. But here's the real shocker. 3I Atlas isn't just coasting quietly. It started leaking water long before it got anywhere close to the sun. In fact, astronomers caught it spewing water vapor when it was about 2.9 times farther from the sun than Earth, well beyond the region where sunlight usually makes a comet's ice turn to gas. At that extraordinary distance, 3I Atlas was already acting like a comet on overdrive. How much water? Roughly 40 kilograms per second. Picture a fire hose blasting away in space. That's about 88 pounds of water shooting out every second. For context, at 2.9 astronomical units from the sun, water ice should still be frozen solid on a comet's surface, so seeing a cosmic sprinkler spraying full blast out there was completely unexpected. Why on Earth, or in space, was an interstellar comet gushing out water in the freezing outer solar system? Scientists were baffled. This just doesn't normally happen at such distances. And then came another surprise. A chemical shocker from the James Webb Space Telescope. When JWST analyzed 3I Atlas's coma, the cloud of gas around it, it found an extreme composition. This comet is unusually rich in carbon dioxide, CO₂, compared to water. In fact, the CO₂-to-H₂O ratio in 3I Atlas's gas is one of the highest ever observed in any comet. Translation: it's releasing tons of carbon dioxide, but relatively little water vapor. That is chemically off the charts compared to typical comets from our solar system, which usually have water as the dominant ingredient. This interstellar traveler is basically rewriting the chemistry rulebook. A comet loaded with CO₂ like this is highly unusual. It hints that 3I Atlas either formed in a very cold, CO₂-rich region of its original star system, or perhaps it went through some process that depleted its water ice. Whatever the cause, the James Webb data stunned scientists, revealing that 3I Atlas isn't built like the comets we're used to. So, what does all this mean? In short, 3I Atlas is defying our expectations at every turn. This interstellar comet is behaving in ways that just don't fit the standard model of comet activity. A visitor from another star blasting out water way too far from the sun and carrying an alien mix of gases has astronomers shaking their heads. As one researcher put it, every interstellar object so far has been a surprise. ʻOumuamua was weirdly dry, Borisov was rich in carbon monoxide, and now Atlas is spraying water where we know it shouldn't. Each one has forced us to rethink what we thought we knew. 3I Atlas in particular is breaking the mold. It's a cosmic curveball that's telling us there's far more variety in other star systems than our theories predicted. In other words, this discovery doesn't fit the model. And that's exactly what makes it so exciting. It's a giant clue that there's something new to learn here. setting the stage for scientists to figure out why this comet is so different and what secrets it might reveal next. Have you noticed a pattern with our cosmic visitors? First came one ʻOumuamua in 2017, a complete oddball. It was dry as a bone with no cometary halo, more like a tumbling space rock than an ice ball. To top it off, it even sped up in a weird way as it left the sun like it had some invisible push, leaving scientists scratching their heads. Then 2 years later, Borisov showed up. Borisov looked more like a traditional comet, finally a tail, but guess what? It turned out to be loaded with carbon monoxide. In fact, it had a higher concentration of CO than any comet we'd seen at that distance. Imagine a comet overflowing with a gas we usually only see in tiny amounts. It's as if Borisov was brewed in an extra cold cosmic freezer where CO ice was abundant. And now we have 3I Atlas, the latest interstellar interloper, and it's bringing its own surprises. Atlas is definitely comet-like. It sports a bright coma and tail, but it's hyperactive. How hyperactive? Even when it was way out past Jupiter's orbit, it started blasting out water like a fire hose on full blast. Observations showed it was shedding about 40 kilograms of water per second, an absolute torrent of vapor long before reaching the inner solar system. And the James Webb Space Telescope revealed something special about Atlas's makeup. This comet is unusually rich in carbon dioxide. Its CO2-to-water ratio is among the highest ever seen in any comet. Atlas is fizzing with CO2. So recap. One interstellar visitor was a dry, rocky oddball. The next was a gas-loaded comet with excess CO. And the third is a CO2-heavy, overactive comet that woke up early. 3 objects, 3 radically different profiles. Each one of these celestial visitors broke our expectations in a different way. It's like the universe is sending us a trio of postcards from completely different planetary systems. With ʻOumuamua, we learned that an interstellar object might look nothing like the icy comets we know. Borisov showed that even a seemingly normal comet can hide an exotic chemistry. Atlas is teaching us that comets can be bigger, older, and far more volatile than we ever imagined. This diversity isn't just trivia, it's a big clue. It suggests that the recipe for making comets and planets can vary wildly from star to star. Our own solar system no longer looks like the universal template we once assumed it was. In fact, as one astronomer put it, ʻOumuamua was dry, Borisov was rich in carbon monoxide, and now Atlas is giving up water at a distance we didn't expect. Each one is rewriting what we thought we knew about how planets and comets form around stars. In other words, everything we thought was standard might just be one local flavor of a much bigger cosmic menu. All this leaves us with a tantalizing mystery. If every new interstellar comet upends the playbook, then what else are we missing? Why didn't our models predict any of these bizarre visitors? It's a humbling wake-up call. Maybe it's time to go back to the drawing board and rethink those models from the ground up. Because if our textbook theories can't explain cosmic objects as different as a rock, a CO-heavy snowball, and a CO2 geyser, then something in our understanding is off. So what are our theories getting wrong? And how can we reconcile these surprises with our ideas of planet formation? That's the bigger puzzle we're now facing, and exactly where we're headed next, as we dig into why our trusty models keep failing to predict these cosmic curveballs. At nearly 3 times Earth's distance from the Sun, a zone so cold that water ice should stay frozen, 3I Atlas was already gushing water vapor like a fire hose. That's not how comets are supposed to behave according to the standard rulebook. And then came another surprise. James Webb's first look revealed about 8 times more carbon dioxide gas than water in Atlas's hazy halo. No current comet theory saw this carbon-heavy cocktail coming. We've seen this before. The first interstellar visitor, ʻOumuamua, was so bizarre that scientists dreamed up wild ideas, hydrogen icebergs, alien tech, to explain it. The second Borisov had such extreme chemistry that researchers speculated it formed around a red dwarf star or was a fragment of an icy planet. So what's really going on here? Are our comet models missing something fundamental, or are these interstellar wanderers rewriting the rules right before our eyes? Our first models might have fallen flat, but scientists have some bold yet bounded hypotheses for 3I Atlas's strange behavior. No need for aliens or magic, just creative, testable science. CO2-rich origins. Perhaps 3I Atlas formed in a region of its home system chock full of carbon dioxide, meaning it picked up extra CO2 ice from the start. Insulating crust. Maybe an extra thick icy crust keeps water ice trapped inside. Sunlight could only heat the surface enough to release CO₂ gas, while water stays frozen until later. Cosmic radiation. Over millions of years in interstellar space, high-energy cosmic rays might have altered the comet's surface, breaking apart water and leaving a CO₂-rich layer. These ideas might sound wild, but they're grounded in real science, and crucially, they're testable. Each hypothesis makes a clear prediction scientists can check as new data arrives. As Webb and other observatories gather more information, we'll find out which idea holds up. Will one of these explanations hit the mark, or will 3I Atlas throw us another curveball? Either way, the story of this interstellar visitor is just getting started, and we can't wait to see what surprises come next. Scientists are pulling out all the stops to study 3I Atlas. They've got telescopes everywhere pointed at this interstellar visitor. NASA's James Webb and Hubble in space, big observatories on the ground, and even a Mars orbiter snapping photos. It's a cosmic stakeout to grab every clue while it's still here. But this opportunity is vanishing fast. 3I Atlas is hurtling through the solar system at around 130,000 miles per hour, so only weeks remain before it slips back into deep space. Researchers are racing the clock to learn all they can. They're watching how the comet's chemistry changes as it heats up. Webb found it unusually rich in carbon dioxide, so will that change as more ice vaporizes? They're also refining its size. Hubble images suggest the nucleus is only a few miles across at most, and scanning for any hint it might be coming apart. After all, the last interstellar comet Borisov actually broke into pieces. Will Atlas hold together? Every new snapshot could bring another surprise, like a sudden outburst or a fragment breaking off. This story is still unfolding. If 3I Atlas was such a surprise, just imagine what the next interstellar visitor might bring. So, what do you think? Could interstellar visitors like 3I Atlas be ferrying the building blocks of life from star to star? Or will discoveries like this force us to rethink everything we thought we knew about how comets form? If you enjoyed this cosmic journey, be sure to like this video and subscribe so you don't miss the next discovery.